Well, now let's go to Earl Hackett. And Earl does our CD stuff. And he hasn't gotten me to the point where I'm ready to try the CAD, but he hopes to get me there. So Earl, welcome.
Hello there. Yes, we're going to proceed along with this bunkhouse tonight. Can you hear me?
Yes.
Okay, great. Fire this up. Oh, first got to share the screen, don't I? Share screen, share. Okay, now I can start it. There we are. Going to talk about component design and joining. Remember, this is the building I'm working on. This is the bunkhouse at Thurman, West Virginia. Long since taken down, but I do have the plans. And let's see. There it is. One of the things we had to do was break it down into parts. So we have 3 parts that, or 6 parts: top of the 2 roofs, 2 wall sections, and 2 foundations. If you're going to, one of the problems you have is you got to put these things together, and you have to join them, and the joints have to be pretty good quality. I had these in the wrong order. If it's a small building like this, it's a relatively simple task to put a little escutcheon up on here, a little plate up here. This guy just snap on top of it and you glue the door, the stairs on later on. Very simple to do. And this is the as it was structured for printing. This was a mistake. I screwed up here on this, the way I did this. And I'll show you, you'll see what I mean later on. We'll go through it, see if we can pick up where the mistake was. Okay, the interfaces that we're going to have, there are some important requirements. The joints have to be easy to conceal, small enough that they're easy to finish, or small enough that they're easy to finish. They should have some sort of mechanical alignment, and ideally, there was some way of locking the parts in position prior to applying an adhesive. And there is a learning curve to this. We finally got 6 pieces that actually work. Numerous parts that we had to scrap because they just didn't work. And this is one of the problems you're going to have. Whenever you're printing with one of these liquid printers, this is where you get the real fine detail. That you're not going to get the fine detail you want from an extrusion printer. They're very good for structural things like switch machine components or something like that, but you're not going to get the fine rivet detail. And the problem we have here is you have to put this thing down on the exposure plate, expose it, and then you have to lift it off. So in the lifting off process, all these yellow sections here have, I guess you call them supports. They call them supports anyway. And this is what they would look like. They go down and they attach to it. This happens to be a slicer called lychee, I guess I pronounce it slicer. And it is very good for manual supports. If you're doing a small, very intricate thing, you might want to use this. But if you just turn it loose, like I did here, it just throws stuff all over the place, and it's not very well organized. A better one that comes with the Elegoo printers is called Chitubox. And you can see here, the support points are very evenly spaced all along this edge here. And they're fairly uniformly spaced throughout the whole structure. The problem is that on that, where those supports join in, you have all these little dimples. And in between those dimples is an area which wasn't supported when it was exposed. So it's basically just a floppy piece of plastic that formed these undefined surfaces. You don't want that surface to show up anywhere you can see it because you're going to have to sand the whole stinking thing down, and that takes a lot of time. So what I did, I stood the model up like this, and all the support pieces are attached underneath the roof or cross sections or underneath the floor places where you can't see it. You see the mistake yet? No, it was not obvious to me either. One of the things you want to do is go around and make sure that it doesn't throw in these supports like this. This thing is really doing nothing for you. It's just going to leave a dot that you're going to have to remove. So it's a whole lot easier to just go around and inspect it and just click on the thing and say delete, and it goes away. Another problem you have to consider is that the way the lights work. With the LED systems, they have a series of LEDs sitting down here. They have collimators with just opaque boxes. And on top of this is a liquid crystal display, which is either opaque or clear. And the liquid crystal display is what determines what gets polymerized and what doesn't get polymerized. Now, the problem you have is that light comes in, it can come in at an angle. And as you can see, the blue area here is polymerized. And what it's doing, it's encroaching on this area that you wanted to have open. So your open areas are going to be a little bit smaller than what you expect. So you have to plan for that with adding some clearances. And what I find is somewhere around 0.1 or 0.12 millimeters is for small parts is adequate clearance. You're going to have some error because this is a digital system. An LED is either on or off, and the LEDs are about 0.02 millimeters square. That's the size of your pixel. So you figure if you have if it goes the wrong way, it'll close you in. With a 0.12 or so, you're going to have enough room to get by. Now, here I'm showing this 0.1 millimeter. I have the window frame down against this edge, and that's the distance of clearance I have here. Otherwise, we might have look at here 0.06, and over on this side here, it's 0.07, so that it adds up to what you're looking for. And now you're going to see the problem. Well, not yet. Yes, you do. The problem was that printing the structure upright, right side up, meant this surface here, where the lintel is going to go, was that crappy dotted, undefined surface. And it extends into this little tiny area. So this area was almost plugged up. And I had to go in there with a feather file, a feather edge file, and clean it out. And that took a long time. It may have been smarter just to print another one, but so finally on this one, I turned it upside down, and it was very easy to clean up because now you just had a flat open surface here. You just take a file in there, 3 strokes of the file, and you're ready to go. So you're always going to have some cleanup to get a good fit. But planning out where you're going to put the ugly surface can make things a whole lot easier for you. This printed this way, these windows took me all of maybe 5 minutes to clean up with a file. The other way, it took better part of a half an hour or maybe an hour. Another thing you want to think about when you're positioning stuff, a lot of times most of these things will say, do you want to automatically position? It'll position it for something, or I'm not sure what it is that they're positioning for, but they put it in some screwy angle so that only one point is down at the bottom. So you don't really have too much of the messy surfaces are pretty much gotten rid of. But when you do that, you can see the striations here. Each one of those is a print surface. So if this thing's printed this was printed at a 15 degree angle, but even at just that slight angle, you can still see this layering effect. And if it's an area where you're not going to see, like this would be the floor of the building. You don't really much care, but if it's on the side where it's obvious, it'd be very distracting. This is the same part, but in this case, I printed it flat, and there's no layering at all. It's just one. When this thing broke off, it was one big piece. It just came off in one chunk. And that's a problem also. And I'll get to that in a little while. One of the things that you really want to do in component design, you want to somehow lock these things into position while you're gluing them up. In this case here, I just put a couple lumps sticking out of the side here. And the object was they would be encased in the stairway. So the stairway has an opening, and they slip right into it if you get the right size. May have to clean them up a little bit, but they slip in. They hold the whole business together in position while you drop in a couple drops of ACC and lock the whole thing up. Another thing you want to think about is how am I going? This would be an internal wall, and once I put this thing in there, I can't get to it with my fingers to position it. So I'm using mortise tenon. This does not have to be a real tight fit because it's an interior wall. You really can't see the seam. It's up in the ceiling anyhow, but you want it to be lined up while you glue it. And so the mortise just slides into this, the black mortise here slides into this green tenon, and it lines the thing up while you glue it. And these are all very easy to produce. One of the bigger problem is when you're out on the outside corners. An outside corner like this, it's not an easy thing to line up. So what I've done, this black section, this is one piece. I took the back section of the wall and extended it a little bit. So this forms a pocket, a 45 degree pocket for this wall to slide into and lock itself in place. We cut this pointy part was cut off so it wouldn't go in here and foul things up. Yeah, if there's any kind of, this is probably not a perfectly good corner, so you don't want to go in there. But what happens? It winds up pretty doggone well, and it's not easy. It's not hard to hide. I still need to do a little bit more cleanup. I'm not completely happy with it. This is how it looks. You really can't see this crack with the naked eye. This is about a 4x magnification. But this side here has been primed. This is the raw plastic, and it's just sitting there. It's not been assembled yet, so these lines are not quite lined up. It's just sitting on the foundation plate. But that looks like a pretty reasonable way to get things to come together and be held in place while you're gluing stuff. I did assemble the foundation frame. The whole thing is built on pilings out over the river. Well, not over the river, but over the bank that goes down to the river. So we want to put a plate in here or something to add dirt to make it look right. But I just used the washroom. The washroom has to fit over these two, and they're going to be assembled. And so before I glued it, I made sure the washroom fit on there, held it together, and then we added glue, but I made sure I didn't get glue right in this area here, so I didn't glue the washroom to the foundation prematurely. So the other thing we did for the foundation, the frame, was we took tabs underneath this one. The green one has a tab that comes down, slides underneath this bar here, and the black one or the white one has a tab that slips down and goes underneath the green bar. So these will hold this thing level while you're working on it. But you find out that the bottom side of these bars here is the ugly edge, all those little bumps and lumps. So before you can get that thing glued, you have to go down, file it down, clean it up a little bit so that these edges, this surface and this surface here, are flush. And that took all of maybe 10 minutes to get that adjusted. But once it's adjusted, it holds everything in position very nicely while you glue it. This didn't work out quite as well as I thought. I may redo the roof sections, but to get the roof sections lined up while you're assembling them, I made a little plug on one side, on the green side, and I just have the surface of it here outlined in red so you can see it. And this slips inside one of the joists and collar ties on the other section to hold this whole thing in position. But I should have made these much beefier. Maybe this is maybe, well, 10 thou penetration. I should have probably made it 1/8 of an inch or something like that. So you really have some structure to work with. So it holds it, but it's not real solid. Probably I might go back and redo these and make it a much heavier junction. And one of the nice things about doing these, you may have noticed that all the windows on the structure are all empty. There's nothing there. What I do is I build the frames, the window frames, and the window sashes as separate parts, paint them, and then assemble them. The sashes will have, they'll be glazed independently and glued in with the glaze already in, so you can position them as partially open or whatever you want. But you can see here, this one is the frame for the door, and the door is and the whole thing just inserted in there and glue dropped on the back, and the whole thing sits on the frame here. This is what they call the filter house. Apparently, they're just pulling water out of the ground and not exactly clean water, so they kind of throw a filter before they fed it to the engineers and firemen and such. But eventually, the steps will go on here, and I'm not sure where the ground is going to be here, so the steps are a little longer than probably necessary. Now, the thing with these printing materials, and I'm going to have to go into this in some detail later on. When you go to paint them, any of the solvent paints, like I've tried old Floquil, Scale Coat, True Color, they all work fine. These are painted in Scale Coat concrete. But these colors here, these 3 grays, this is actually a gray, very light gray, but it is a gray. These are all custom colors, and they're latex, acrylic latex from Home Depot. I just went in and grabbed a whole bunch of their gray, and they have like, I must have 200 colors, shades of gray. And I had some paint swatches back here that I wanted to have it as close a match as I could get. So I came back and found some paint colors that matched them exactly. So the one I don't have to sit down and try and do a color match every time I build a new structure. A quarter of the stuff is going to last me the rest of my life. Now, for grays, you can go to an automotive store and get automotive paints because they have a huge range of gray scales that we could probably get to fit. They're solvent based, and you don't have to do anything special. But an acrylic paint will not stick to these 3D printed materials. They just peel right off. So this was initially primed with a Krytox, and then you can stick the acrylic paints will stick very nicely to that Krytox primer. So there you go. That's the story for tonight. And next week we'll get into the details of how you spray paint these things. I just brush painted this because it's a small structure. I just brush painted it for tonight's presentation. But the larger structures are going to have to be spray painted, and we'll get into how to do that hopefully next week.
Earl,
Okay, that's it for that. Yeah, shoot.
I have a question. What do you use for filler on your 3D part
For what?
before you paint it? If you have
the
a coal or something, you want to fill it, what do you use?
I'll just use a what they call spot repair material for automotive finishing. Comes in a tube. 3M makes it. You just trowel it on, scrape it off, and you might do a little scrape. It's easy to sand and scrape to make it clear.
Thank you.
Fill up any hole.
Thank you.
But these will respond to anything that is anything that's solvent based will stick to these plastics. But acrylics, water based stuff, forget it. They will not stick.